You're listening to the Maritime Gardening Podcast brought to you by Vessie's Seeds. And today we've got Richard Zurawski here to talk about rain. Who is Richard Zurawski? He's a meteorologist, a documentary film producer, TV host, writer, author, public speaker, university lecturer, a media personality. And on top of all of that, I don't know where he finds the energy. He's currently running for council in his district. We don't talk about politics on the show here. Just adding that to the list of things to show the energy this guy has. And I don't know where he finds it. So Richard, say hello. How are you doing?
I'm doing well. Overworked and underplayed.
Overworked and underplayed. You probably also got a book in the works, I assume. You always do.
Yes, I do. Yes, I do.
What's your current book you got
Well,
on the
the current book is about how it's basically about the war on science.
Oh, okay.
But globally, science is being discounted and the ramifications of why this is important and why journalists basically don't understand science and why the reporting is so poor on science.
Right. Well, I'm right there with you. That sounds great to me. Speaking of science, today we're going to talk about rain. I guess science and math, a lot of probability when it comes to forecasts and rain. And I thought we'd start off by just talking about how to interpret the forecast, because you look at the forecast, sometimes it'll say it's sunny tomorrow. Sometimes it'll say it's going to rain tomorrow. But other times it'll say there's a 30% chance of showers or 30%, 60% chance of rain, that sort of thing. And I thought maybe you could give us a meteorologist's.
Okay.
For those that don't know, Richard spent a number of years as the weatherman on one of the local TV stations here, and also he had a TV show called Wonder Why, which is kind of like a science show for kids. Very industrious uh, television career for a good run there. So yeah, I'm looking at the forecast right now for tonight, and it says partly cloudy with 30% chance of showers, fog patches developing overnight, and so on and so forth. So when I see 30% of showers, what is that to me? So, and this is the forecast for Halifax, according to some boundary, I guess, maybe Halifax, the city. So what does that mean, 30% chance of showers?
Okay, so when we allocate the possibility of getting some precipitation, we break it down into drizzle, showers, and rain. The first thing is fog and drizzle is usually systemic, or it can be just the fact that the humidity is high because the temperature has fallen, and you wind up with fog and you wind up with dew coming in. But what you're talking about specifically has to do with the probability of getting any precipitation within the grid that the forecast is taking place in. So that's within Halifax. At
Right,
any given place, at any given time, there's a 30% chance of getting some rain. And we call that basically showery activity. So
right,
the rain that comes down won't be lasting a long time. It could be heavy in downpours if you happen to be under a thunderstorm or something like that. But basically, 30% is pretty much as close to not getting rain as you can get without discounting the fact that it's going to rain. So at 30%, it's not very likely to rain. If
right,
you see 60% or 90%, well, then you know it's a large system coming in. It's systemic type of rainfall. So interpreting the forecast requires a little bit of understanding the geography. And very often what they'll say is coastal areas will get more or less, or
yes,
the prevailing winds, depending on which direction they're coming from, will give you more or less in a given area. So it's
right,
very difficult to isolate exactly where you're going to get rain. In the forecast, the rain is probably the most important thing that people look at. Uh,
yes,
they get an idea of what the temperature is because of the season. If we're approaching into fall, so we know there's going to be a chance of frost in the daytime hours, switching over to fall. Temperature is likely to be between 16 and 20 degrees. So you get that basic idea. So the big question becomes, how much rain are we going to get? It's going to be a nice sunny day, or is it going to be one of those days where I have to grab the umbrella?
yeah. So I always think like if it's 30% chance of showers, I don't cancel, if I'm going to go apple picking or, fishing or hiking or something like that. 30% chance of showers for me is just go for it. If it's a really warm day, I might not even bring a rain jacket. And if it's a cold day, I will because I don't want to be cold and wet. Um, is that a good way to read it?
Bingo. That's
Yeah,
exactly the way I interpret it as well.
yeah,
And
yeah.
at 30%, I'm willing to take the risk. At 60%, it's kind of, my laziness gets the better of me. I'll stay home.
Yeah, or like if you're going out, prepare for rain. You might be pleasantly surprised. There might be rain in the area you're in, but it might miss you, but it might not. So, prepare for rain and be pleasantly surprised if you get lucky.
Yeah,
Otherwise,
that's
um,
it.
I'm looking at I had a range of questions here for you, but I didn't have any. I mean, this falls within the category of rain because it's got something to do with the amount of water in the air. I didn't have any questions about frost. And since we're just where we live anyway, we're
Mhm.
just getting into frost warnings. So this has always been a question of mine. So, I mean, we know that water freezes at 0 degrees Celsius, but you'll have an evening last night. It was 7 C overnight, risk of frost.
Yeah.
How can anything freeze at 7 degrees above zero?
Well, what happens at this time of year is that you look at the high ground and the low ground. And if you've got some moisture in the air, if you do get some dew, chances are that will protect your plants and keep the temperature up. Because in order to create the dew, the condensation, the water vapor has to give energy and heat into the air.
Hmm.
So when it creates the dew, it actually warms things up. But if you're in a pocket of air that's quite dry, then you could have the ground temperature is quite warm. It rises and the cold air from the top falls down, and you have a risk of frost.
Hmm.
So once you get around 5 degrees, the risk of frost is running at about 50%. If
Right.
you're above that, it declines very rapidly. And if you're at 3 degrees, if you're forecasting a temperature of 3 degrees, there is probably more than a 50% chance that some areas will be getting some frost precisely based on the amount of moisture that's in the air and how much energy you can get out of condensation. So if you want to keep your plants protected at a risk of frost, the best thing to do is get the garden hose and sprinkle them and make them wet.
Really?
Uh, Once they're wet, in order to freeze the water that's on the plant, it has to give off energy. In other words, to translate from liquid to a solid, it will actually heat up the plant, which
Really?
seems counterintuitive. It seems kind of weird. So,
Yes.
um, when you want to protect your plants, take out the garden hose and sprinkle them with water. That will help.
I've heard about in Florida, they literally run some sort of misting type thing. When there's a risk of frost, they just run this thing almost like a light rain effect over the like orange orchards or that, that sort of thing, to protect them from the frost using the same effect I think you're explaining right now.
So what that's called smudging. And
Smudging,
what they do is they open up the smudge pots, which create little particulates.
right?
And the particulates act as condensation nuclei in the air. And the condensation nuclei congeal water around them, which forms water around the fruit, and that keeps it from freezing.
Wow, that's cool.
Yeah.
Now, stepping back about just talking about rain in general. How does rain form? I mean, this is all stuff we're taught in school, but then we forget about it and we don't really understand what's going on up in the sky. Uh, yeah, so what's going on? You know,
Okay, so in almost all areas, and especially in the Maritimes, there is some water vapor. There are very few places that don't have water vapor in the air. The Sahara Desert, the Antarctic, the high Arctic, all the water vapor is frozen out. The rest of the world has some water vapor, excuse me, in the air. So it depends on whether the temperature is rising or cooling, whether or not you're going to get the vapor changing into a liquid form, which creates droplets. Now, if
right.
there's no wind and the air is very stable, you will wind up, if the temperature starts to fall and there's sufficient water in the air, it will form a fog. And fog is actually a cloud that is on the ground level, and the droplets are tiny. They're on the order of um, a hundredth of a millimeter in diameter. So they actually suspend themselves in the air. If there's a little bit of wind, rising air, falling air, or air moving horizontally, the droplets will start to collide with each other and they'll actually get bigger.
Right.
And that's an accretion mode. And
Right.
so they will accrete and become heavier and heavier and heavier. And at some point, they begin to fall.
I
And if it's
see.
heavy enough, you'll wind up with rainfall, showers, or heavy rainfall or continuous rainfall. So it depends on the amount of water vapor you've got in the air, and it
Yeah.
depends on getting the temperature down. Either you add more water vapor to it at a given temperature, or you lower the temperature in order to create the condensation. And the other factor is you need little condensation nuclei, little particles of dust
Oh.
around which the water will congeal. So
Oh,
those, excuse me, those nuclei are very, very important. So it helps to have dirty air.
I
So around
see.
cities, you wind up getting that. After a dry spell, you wind up with dust, and those dust particles will create water droplets. So each little droplet of rain has a little tiny particle of dirt in it.
Really?
Yeah.
And by dirt,
So
you
it
just mean
fertilizes.
any particulate. If it could be anything,
Yeah.
right?
Most
Okay.
often, it's stuff that comes off the crustal area of the earth. So whatever the soil's made out of in that particular area.
I see. Okay. So if you've got a lot of clay, it's going to have clay particles, and if you got,
Yes.
I see. That makes sense. Um, so I guess that this, I mean, I'm going to change the order up here, but this segues into a question I had, which, what is in rain besides water? So,
Well, the it's as clean a water as you can practically get. It's actually rain coming out of a normal area. I'm not talking about an urban area that's coal-fired and you've got all kinds of engine emissions and that kind of thing. That's pretty dirty water.
yeah,
Uh, but if you're in a relatively pristine rural setting, your rainfall will be drinkable. It will be very clean and like one tiny particle of dirt in the water. So it'll be a very, very soft water compared to what you'd get out of the ground.
right,
And also, it is water that would conduct a little bit of electricity because of that particulate in there that polarizes the molecules and allows ions to exist, which conducts electricity. So that's also what you get in a rainstorm is the potential for lightning strikes and fires.
And what about, I mean, is there anything else? So you got, you have some little particle, tiny, tiny particle, and a bunch of water molecules, gathering around it,
Yep.
and they're falling through the sky. Are they picking up anything else on their way down?
Yeah, they'll actually clean the air. They'll,
Oh, yeah.
depending on how dirty or clean the air is. And if you're winding up with a lot of rainfall, you'll get a distinct odor, a very pleasant after rainfall
I love that smell. Yeah.
smell that you will get.
Yeah.
And that is from the rainfall hitting the ground, and it releases everything in the droplet that it's cleaned out of the air.
Huh.
So you will actually pick that up in your nasal membranes. And if you get lightning, of course, you'll smell the ozone, which is what a lightning path will make, that pungent kind of odor. But you get that wonderful clean after rain smell because the raindrop explodes and it releases everything. And it, of course, releases everything on the ground as well. It washes the grass and the plants and the leaves and the animals that are there. And it has a number of other effects. One is it'll transmit sound better because it's more dense.
Right.
Another is it will transmit odors better because odors are dependent on the water vapor getting into your membranes and linking up with all the little receptors that you have in your nasal membranes, and you can actually taste it.
So do you mean the moisture helps your nose detect smell, or that the the particles that your nose is detecting are carried better to your nose? on particles of water?
Both. So what
Both.
happens
Okay.
is it's carried better into your nasal membranes, and it also releases the particles that are in the water droplets, so you're able to detect them. So
Wow.
that's why you get that wonderful odor.
I know. Yeah, I love that. It's one of my favorite things. Even on a driveway, you got like this giant tar thing, but it's that smell of rain in a driveway. It's just wonderful.
Yeah.
Um, um, what kinds of places have more rain than others, and why? I mean, we get a lot of rain here in Nova Scotia. I mean, it's funny when you have a gardening channel, right? No matter what I talk about in terms of weather, people always say it's more, like I'll say, here's how you protect blah 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 from excess winds. And someone will say, I live in blah, blah, blah. It's really windy here. And I'll say, oh, this, rain's a problem. And they're like, well, I live over here. It's really rainy here. I think it's fairly windy and rainy here because we're a peninsula on the Atlantic Ocean and so on. I'm sure there's places that are more rainy and more windy. Uh, but what kinds of places have more rains than others? And why?
Okay, so you can be very close to the ocean and have absolutely no rainfall at all. The Sahara Desert is one area. It's bounded by the Mediterranean and the Atlantic Ocean. Parts of the Andes have rain shadow effects. The Atacama Desert is probably the driest non-Arctic or Antarctic desert in the world, where some areas haven't had rainfall in 300 years. So the orogeny, the orographic land shapings are really important, whether there are mountains there and the prevailing winds.
Right.
So the prevailing winds are really important. At this time of year in the Maritimes, we tend to get what is called a Bermuda high, and
Okay.
that has nothing to do with stuff you grow and smoke. So a Bermuda high is an area of high pressure which causes a clockwise rotation that allows southwesterly winds to blow in as opposed to southeasterly winds. So the wind that comes in is actually dry coming in from the continent. And even though we're very close to the ocean, right on the ocean in many cases, we
Hmm.
wind up with extended periods of very dry weather, which we actually got this year for the first time in a number of years. We haven't had
Right.
much rainfall. And it's this wonderful time of year where the temperatures are cool and comfortable. The plants are soaking up all the sunshine they can in order to bear their fruit. They've already had the rainfall in the summertime. And for us, um, the switch will happen probably in a couple of weeks once that Bermuda high breaks down and it shifts further down to the south and we get northeasterly type of weather. So
Hmm.
the importance of the geography can't be overstated. It depends on whether you've got mountains there. It depends on the prevailing winds. It depends on whether you've got a body of water next to you. All of those factors come into it. And then you look at the seasonal aspects of it. Um,
Yeah,
uh,
like why is there rain in fall? Why is fall associated with rain and spring, I guess?
well, it's because the Bermuda High, which we were just talking about,
Yeah.
actually moves further down to the south. And that allows for the formation of hurricanes to link up with low pressure systems until we get to December.
Hmm.
And then that breaks down because the water temperatures aren't warm enough anymore in the south to generate those types of storms. And then our wind switches over to low pressure systems coming in from the continent, usually from the west, and they take up housekeeping. They actually anchor themselves. One's called an Icelandic low, and the other one's called Pacific low off the coast of British Columbia. And they look like two giant owl eyes, which actually filter through their circulation, which is counterclockwise. We wind up with a southeasterly to easterly to northeasterly flow of air, which gives us lots of rainfall or snowfall, depending on the temperature.
This Bermuda High, I mean, is this a cyclical thing or is it something that doesn't always like reach Nova Scotia? Is it always is it a thing that happens every single year, but sometimes it just doesn't reach us?
Yeah, it
This last
happens.
year was rubbish. Last year we got so much rain. It was the
Exactly.
worst summer ever.
So what we had, was lots and lots of hurricanes last year. And so the Bermuda High didn't really get a chance to form. And it got broken down by these disturbances pushing through it. This year, what was interesting is we got a lot of dust from the Sahara Desert, and it pushed across the southern Atlantic. And even though the temperatures were recordly warm, the dust from the Sahara actually produced condensation nuclei, which caused the formation to be inhibited to hurricanes. And so that's why this year we were forecasting an awful year for hurricanes, but we're not really getting it. And it allowed the area of high pressure to reestablish itself. And
Wow.
yeah, it's the interplay between insolation, the amount of sunshine we get, the ocean temperatures, the dust particles in the air determine what our weather is. And right now we're into periods of instability. And this year we got some stability back again, and it surprised us all.
That's so funny. I mean, you could say to someone, so why was the summer so nice? Oh, well, it was the Sahara Desert.
Exactly. I mean, it is a global phenomenon.
Yes.
We get affected by global phenomenons, trade winds that flow over the ocean, and systems that are almost, you can count on them every year, like the monsoons in India.
Yes. Yeah, yeah.
It's the same ocean, it's the same continent, it's the same orogeny, geography, all that kind of stuff. But it's the shift in the Earth's axis. All of a sudden, you wind up with low pressure systems that bring in the prevailing rainfall. And the heaviest rainfalls in the world, by the way, take place in India during the monsoons. The heaviest rainfall I ever saw was 1.5 meters of rainfall in 12 hours in Mumbai. That's 5 feet of water.
That's insane, you
That
know?
is, there were 1,000 people who perished in that from drowning. Um,
Holy smokes.
yeah, so it can be very substantial, and it happens in just a number of hours. And then the monsoons stay. They last about 2 to 3 months, and then they move away. We get some of the same effect in northern British Columbia, but it's more of a temperate thing where you wind up with temperate rainfall and giving us temperate forests and lots of funguses and um, some of the worst weather in Canada, most depressing weather happens in Prince Rupert or St. George in British Columbia on the coast near the Queen Charlottes.
Just because it's overcast and raining for so much.
Overcast, raining, that just doesn't quit. And when it starts raining, it rains for weeks on end.
My goodness, I wonder if I'd like that. I've got what's that called? Chronic sinusitis, like my and I like humid air, right? I really do.
Yes.
I'll often go outside just to get more humidity in my system, because the alternative is this thing you put water up into your brains and it comes back out and you feel like you're drowning. So I'd rather just go outside and go for a walk.
Yeah.
Uh,
So humidity plays a great role in that. So I would imagine it's great for sinuses, but after a while, you've had enough rain. Sinus won't be the issue that you're dealing with.
yes. Um, there's also, I mean, gardeners will call snow a poor man's fertilizer. Now, and this is just in part because it covers the ground. But there is, I guess, some amount of nitrogen in rain. Uh, does that is that something you're aware of, or does that make any
Yeah.
sense to you?
Well, you see, the Earth's atmosphere is composed of 79% nitrogen. So every time you take a breath, you're breathing in nitrogen mostly, and then the other 20% is oxygen, and the rest is trace gases. So what happens is the rainfall falls. It's got its condensation nucleus to make the water, but water is also a polar molecule. So
Okay.
it's got more of an electric charge on one side of it that does the other side of it. And so it will hook up with the nitrogen and grab some of the nitrogen in the air and push it down. Now, um, on a seasonal basis, probably the biggest nitrogen kick you will get is from melting snow. And that's because the snow is accumulated over the winter. The nitrogen is locked in the snow. And when
Oh.
the snow finally melts in the springtime, that fertilizing nitrogen goes in. Incredibly important. So when you get a season without much snow,
Hmm.
it actually affects the soil
Huh.
and wind up with less fertilizer from the condensation nuclei and less fertilizer from the nitrogenosis of the um, accumulated snow.
Huh.
That's why it's so important to have, this regular snowfall, regular rainfall, and relatively clean air. You don't want to be bringing in all the industrial effluents that exist in the Southwest.
Yes. Yes. Exactly. Um, I should ask, I guess that segues perfectly. What is acid rain? And is it still, I mean, I was a kid back in the 80s, in the 70s and 80s, but I don't remember anything from the 70s other than the cartoons and having a good time. But in the 80s, I remember, um, people, the grown-ups in the news were always talking about acid rain, that sort of thing. And I mean, I'm sure there's still acid rain, but it doesn't seem to be spoken about as much. Did we solve it, or is it still with us?
Well, it is still with us in small amounts.
Right.
Um, and the ecosphere can handle a little bit of acid. And acid is determined by the pH, the power hydroxyl radicals, and the lower the pH, the more acidic it is. Now, back in the 50s, 60s, and 70s, in Canada, we had one smokestack that produced 2% of all the sulfur dioxide in the world. And that was the Inco giant smokestack. It was 1,200 feet high. It was that big to push all the effluent, the sulfuric effluent. It was a sulfur dioxide,
Right.
O2. And what happens once the sulfur gets into the atmosphere, and because it's west of us and the prevailing winds are coming in from the west, Northern Ontario, Quebec, and the Maritimes benefited from that. So when you add water to um, a sulfate, you wind up with sulfuric acid, and sulfuric acid is what we had in acid rain. And some of the rainfall that was coming down was stronger than vinegar. They actually recorded some acid rain in Scotland that was uh, I think, a pH that was higher than acetyl salicylic acid or vinegar that you buy in the grocery store. And
Wow.
so it killed, the lakes got very clean because it killed everything off.
Nice.
So if people were looking at the lakes going, oh my goodness, I can see 10, 12, 15 feet into the water, but there wasn't a bit of algae, a bit of seaweed, no animals, no fish. They were completely dead.
That was like a swimming pool, you know.
Yeah,
I
exactly.
see. Wow.
So it's the sulfate, again, the same process. What happened is because, again, condensation nuclei, polar molecule, it grabbed onto the sulfate, the SO2,
Right.
and it formed immediately H2SO4, which is um, sulfuric acid. And if you're a chemist, it's great. If you're a frog or a fish, it means death. And it killed off the maple trees as well.
Wow.
Um,
It's just always spoken about with salmon spawning and that sort of thing.
exactly.
'Cause it affects some fish are more uh, the eggs are more sensitive to it than others. Um, so what were there regulations put in place, or what was, uh, like that's not is that still happening, or is that better
So
now, or is there rules or cleaners or scrubbers or different,
scrubbers. That's what they
scrubbers?
put on the big stack in
Right.
the Inco stack in Sudbury, and they started putting it on all the smokestacks. And in addition to that, we stopped burning coal with a lot of sulfur in it. Coal comes in
Uh,
different forms.
right.
Um, if you look at lignite and bituminous coal, it's loaded with sulfur.
Right.
And anthracite's not quite as bad. Uh, Coal is just bad all around as a power source. But we're diminishing the amount of coal that we're using, although the coal industry is still major source of that pollution. But we now have scrubbers that take the sulfur dioxide out of the smokestacks when we burn them, but we're still putting carbon dioxide in the atmosphere. Um,
Right.
it's a different thing, but that is one thing that I think we can say we've solved. Um, that Montreal Protocol, which happened way back when in the 80s, was very effective.
Right.
We all agreed that this was not a good thing, and we put the scrubbers in. The scrubbers were on the order of billions of dollars for
Oh,
the
wow.
single Inco stack. I don't know if you've ever been to Sudbury, but that is one big smokestack.
I have to, I mean, I went through Sudbury's where they have the nickel, right? The
Yep,
giant nickel. Yeah. So I did
giant
drive through
nickel.
there once, but all I remember is the nickel.
Well,
I should have checked that out.
In Coppercliff, and I grew up in in northern Ontario,
Right.
southern Georgian Bay,
Yeah.
and so going to Sudbury was a relatively recent occurrence to play hockey.
Right.
And that smokestack, they built that 1,200-foot smokestack so that Sudbury wouldn't look like a lunar landscape, because all the refining of the metals, um, and the extraction of the metals in and around Sudbury, they had small smokestacks, and it looked like a lunar landscape. Everything was dead and black.
So you
Uh,
mean all the particulate just comes back down? And if
right.
they
So they
can get
built
it
this.
like high enough up into the sky, it just the sky takes it away. Is that
That's it.
that's it?
Bingo. It's somebody else's problem.
Yes. Do you remember that there used to be a thing on TV? Uh, People don't watch TV anymore, but TV is where we get all our information. And they'd have a guy. There was a man and a boy on a boat, and they had a juice harp playing. That dong 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 dong, and the son finishes his Coke or something like that, and he says, what should I do with this, Dad? And the guy goes, oh, the son says, where's the garbage? And the father says, you don't need no garbage on a boat, boy. Just take it in the ocean. The ocean will take it away. And uh, and then the kid says, where does it go? And the father says, away. And I remember that. That was when I was a kid. It's a shame. They used to have those wonderful little public information things.
Yeah.
And I remember my dad doing that. He'd finish a beer, we'd be out, and he'd just sort of hold it under the water and let go of it. And down it would go. Right? Another question is, are there different kinds of rain? Like, uh, like there might be different kinds of, like when you're in the winter, there's different kinds of snow. You can kind of tell, oh, this is big snow or small snow or that sort of thing. Is it the same sort of thing with rain? Do meteorologists have terminologies for different types of rain?
Yeah, we do.
Oh,
We break it down from drizzle and fog, showery type rain. It depends on the type of cloud it's coming out of. If it's a cumulus cloud, it tends to be showery activity, and the water droplets tend to be fairly big. If it's very stable air, if it's stratus and it's very hydrated and full of a lot of moisture, then it becomes fog, and then it can become drizzle if it gets a little bit bigger. And what's interesting about the showers, if you wind up with towering cumulus or cumulonimbus clouds, these are really large clouds. The cumulonimbus are the thunderheads, the ones that go up to 60,000 feet. You see the tornadoes and all that kind of stuff. The rainfall can stay embedded in the cloud for a long time because of the updrafts, and very often you wind up with hail.
hmm.
So in the summertime, people will say, well, we got 8 inches of snow. Well, it turns out that's actually rainfall that's been pushed up to the stratosphere. Temperature there is -70. So the medium
Ah,
freezes, falls back down again, gets more water on it, gets pushed back up into the cloud, gets another
oh,
layer of water, refreezes, comes back down, and just goes up and down till it gets heavy enough to fall right through the cloud to the ground to give you hail. And so
oh,
that's a type of rainfall, but it's frozen rainfall, even though it could be 30 degrees on the ground. Up at the top of the cloud, it's -70 degrees Celsius.
oh, I see.
And so you wind up with all different types of precipitation. So we don't call it different types of rainfall, it's called different types of precipitation.
I
Um,
see.
because some of it comes down in the form of solid, some of it is switching back and forth almost in a stable way between fog and uh, drizzle
Right.
kind of. And you can wind up with very windy conditions and a stable fog where the wind is not getting rid of the fog. It actually makes it worse by picking up more water particles and
I
adding
see.
to the fog. So it really does depend on the type of cloud it comes from. If it's a steady rainfall, it's a nimbus cloud or a stratus cloud. And that's the type of rain that'll come down for days, where a low pressure system just stays there and you wind up with rainfall. And it's that type of, is it ever going to stop?
Yeah, yeah,
Kind of.
yeah.
And in the wintertime, you get different types of snowfall. Sometimes you get snowfall out of no clouds, which is when the temperature falls below minus 40.
Mm,
Then it just automatically condenses out of the air. So you wind up with what are called ice crystals.
mm,
And then you wind up with freezing precipitation. In the States, it's called sleet, where it comes down as a liquid, but then when it spreads out, it actually freezes. So it's super cooled until it
mm,
touches something. And so we get that in certain winter storms. The ice storm in Montreal back I guess it was the late 80s that did all that destruction,
mm.
uh, went on for a week and a half and caused billions of dollars of damage.
Yeah, yeah.
So it's different types of precipitation based on the type of cloud it comes out of and the type of weather system. The best that you can hope for is a nice, gentle 20 to 30 millimeters of rain over 12 to 24 hours, and then a couple of days of sunshine. And those are the normal patterns that we like to see in the Maritimes. Every third day, you get a little bit of precipitation on average in the summer.
I mean, my wife's from Southern Ontario, right?
Yep.
She moved here with me in 2003. And, I lived in Southern, I met her when I lived there. I was in graduate school there for 6 years. And the one thing I noticed living there was that the weather was just more stable there, generally speaking. Um, and then she was kind of shocked moving here because it's just like you got all these different snows. You got, rain, snow, and fog snow, and all the
Right.
ice snow, and sun snow, and all this sort of stuff. She's just shocked at the sort of the instability, how much it changes, all these different varieties. Right,
In Ontario, it is more stable because it's a continental climate.
right,
So it's less water vapor in the air. Without water vapor, you can't have weather.
right.
Uh, Water vapor actually transmits weather. It transmits temperature. It acts like a battery. So you
Uh,
end up getting from the equator a lot of warmth in the ocean. It goes into water vapor, gets pushed up to north, and it then condenses. And when it condenses, it gives off heat. And so that's why we get this crazy weather, because with the precipitation comes the absorption of heat or the transmission of heat, depending on which season you're in. And you don't get that in a continental climate to the same degree that you do in a maritime climate.
right. Just the other day, I mean, this was maybe a week or so ago. It was a really, really hot day, and I met a friend for lunch downtown, and it was really hot. It's the kind of heat where you got to walk slow or you sweat through your clothes.
Yeah.
And we went to the restaurant, um, and we ate hot food. So I was really worried about having to walk back to the office in the heat. But it had rained while we were eating, and it was like 10 degrees cooler outside. Um, what is happening when you have a rain on a hot day and it just you can literally feel the air. It's just, I mean, sure, the rain clouds appear and they block out the sun and that sort of thing. But I mean, we came out, it was sunny. It had clouded over and rained, and then it resumed being sunny. So you couldn't really tell it had rained, except that the temperature had dropped
Yeah.
dramatically. So what's going on there?
Well, what you had was you were in what was called the warm sector. So you've got a low pressure system going off to the north, and you got a warm front, and you're in the warm, humid air.
Right.
And it's sticky, unpleasant, and you go and you have your meal. And in behind it is a cold front. The cold front wedges underneath the warm air, throws it up, and that's when the rainfall happens.
Oh, I
And
see.
then the cold front moves through, and then you're in this beautiful, much clearer, sunny skies. And the wind is shifted through from the southwest or south to the west northwest, and it feels like well, it is a breath of fresh air, and
Yeah,
it's clean
yeah.
air because it's coming in from the north, not the industrial heartland,
Yes.
and it's cooler and less humid, and that 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 happens here, and it happens in other places, but not to the same extent that it happens here because
Right.
we're kind of, the nexus of all the weather systems coming in.
Lucky us. Sometimes
Yeah.
that's great. Sometimes it's not so great when the roof disappears off your house, that sort of thing. Um, I was going to ask you, there's a thing that some countries do. I don't know if it's legal here, but it's called cloud seeding, where they can take a cloud and make it rain, either to grab rain out of a cloud or to prevent rain for an event. What is that?
Well, it's silver iodide,
Right?
and this happened. There's a long story with this.
Okay.
Um, there used to be a group of people. I'm going to give you a bit of a background on this.
Okay.
Um, they were called rainmakers, and it's a trick that meteorologists use. So on a nice sunny day, you're in a nice area of high pressure, and you look at a cloud, and the average lifespan of a cumulus cloud, they happen where there's updrafts of air. So when the air rises, it forms the cloud at the condensation level. And then when it moves, there's the downdraft, which takes the cloud down and it re-sublimates back into the atmosphere. It
Okay.
goes back and becomes invisible. So the average lifespan of a cloud in the Maritimes on a nice sunny day is about 10 minutes.
Really?
Yes.
Huh.
So if you watch a cloud, it will form, move, dissipate, and disappear
Hmm.
on that cloud. But because it's cloud after cloud after cloud, you don't sit there staring at the cloud for 10 or 15 minutes. But rainmakers in the States back in the 1800s, where it was very dry in Kansas and Nebraska and North Dakota and South Dakota, this one guy was very famous. He made up this contraption, and he knew the clouds would dissipate, and so he said, I can make rain, and I've got this wonderful machine that will do it, and all I have to do is point it at the cloud, and it's got bells and whistles and lights and all kinds of stuff. And I'll to show that it works, I will make that cloud disappear in 20 minutes. And so he would get money. He said this costs money, a little bit, but not much. Making a cloud costs a little more. So I'll show you first that I can make the cloud go away. And
Right.
so and these rainmakers would prey on the towns and villages with their weird contraptions and actually do this. And so silver iodide is not far removed from the rainmakers.
But the rainmakers, just to be clear, they weren't making rain. They were
No, no,
they
they
were
were
making
making
clouds
money.
disappear and saying, "Okay, give me some more money and I'll make some rain," and they leave town or something like that. Is
And yeah, that's give me the money, and then I will tomorrow show up with my
yes,
machine. In the meantime,
yes,
I'm clearing town. I'm heading out
yes,
on the next train.
right.
So silver iodide was tried in North America during the 1950s and 60s, and it was really shown not to really have much an effect. It's again using silver iodide as condensation nuclei to
Yes,
condense the water vapor out. And it really didn't do much. So we stopped the practice. And in certain parts of the world where even a small amount of rain is critical, then it matters. There's not too many places in North America where it does. In Arizona, you'd like to see some rain, but there are no clouds. The clouds are so high that silver iodide wouldn't work. So it's basically a chimera, um, a nebulous little fantasy that it works. They they did use it for certain festivals at certain times to cause rainfall to happen. It did a little bit. It was going to rain anyhow, so it really didn't clear things out. So it's legal, I suppose,
right.
but it doesn't really work. Most of the evidence shows that it's just basically uh, up there with the Chautauqua uh, rainmakers.
I see. Um, So what about the, like we'll have these, people say in fishing anyway, they'll say when when the wind's in the east, the fish bite the least and that sort of thing.
Yeah.
Does the direction of the wind affect rain? If
Yes,
it's
it
coming from
does.
the north or the south or the east or the
Yeah.
west?
Yeah. First of all, it also affects the number of bugs that you get in the air. When
Really?
bugs' wings get wet, they can't fly.
Hmm.
A water droplet for you and me is not much, but a water droplet on a fly is like carrying a house around.
Yes.
So when you get precipitation, heavy precipitation, you wind up, it usually comes from the east, southeast, which is where most of our precipitation comes from. Um, then you won't get much in the way of good fishing. And a lot of these homilies, these weather homilies, are based in truth. Red
Really?
sky at night, sailor's delight, red sky in the morning, sailor's warning. That is because of the amount of dust particles in the atmosphere. So in the morning, you're seeing dust particles in the east, and your weather systems are coming in from the east. And that's not good weather. If you're seeing red sky at night, you're basically looking at dust particles in the west as the sun sets, which is a normal occurrence, and you're not getting any rainfall. If you're getting northeasterly winds, chances are you're not going to get the fish biting because it's going to be a storm. There aren't many bugs in the air, so they're not feeding in the same way.
That's what it is. It's feeding
Yeah,
activity. Oh,
yeah,
they're just going to be less dialed up sort of thing.
that's right.
Oh, I never knew. Huh. I thought it was like it's cold or something like
Yeah.
something
Well,
like
then you
that.
can wind up. Temperature is also important in the water because the colder it is, the more oxygen there is. And in the summertime, very often windstorms will turn over the water and it'll push the warm water to the bottom and the cold water to the top. And of course, in order to get the oxygen, the fish will go up to the cold water at the same time.
I see.
So,
Yeah, yeah. Makes
so
sense.
it helps to be a meteorologist and a fisher.
Yes. No, it would. Yes. What about the old saying? This is a snow thing. Little flake, big snow, big flake, little snow. Ever
Yeah.
heard that before? Like if so, that
Yep.
basically saying if the flakes are small, you're going to get a lot of snow. If the flakes are big, you're going to get not as much snow. Is there anything to that?
Yes, there is.
Really?
Usually, in order to get the big snow, the big fluffies, what you need is a very stable air mass and a slight temperature and change to cause the condensation and then the accretion of the crystal. And so, usually, you don't get much precipitation out of that.
Hmm.
It's very stable. It's not moving quickly. And so even though there's a fair amount of water vapor in there, you're not getting a lot of water vapor condensing out into ice crystals,
I see.
or a lot of water freezing out into the snowfall. If you're winding up with small flakes, that's telling you you've got a frontal disturbance coming in. And if you've got a body of water that's open, it'll pick up a lot of moisture and you wind up with um, uh, snow coming in huge snow belts. You get that in southern Ontario. In the London Kitchener area, they're in a snow belt. In certain parts of Georgian Bay, you get that off Lake Huron as well.
Oh, because the weather's passing over a Great Lake.
Yeah, yeah.
I
And
see.
so if you wind up with small crystals, it's fairly windy, it's picking up a lot of moisture, and it's creating a lot of crystals that will fall in the form of snow. So you get a heavy snowfall,
I should
heavier.
ask you about, do you remember 2015? We had this crazy snow. It was the worst garden I ever had, and the ground was still frozen in June in places.
Yeah,
But we had like I remember in the woods the snow because I snowshoed and I marked trails. And once everything thawed out, my markers were like 9 feet high in the trees. We had like 4 feet of snow.
yeah,
The lake behind my house, which is usually thawed uh, before April, but at least by April, that lake didn't thaw till I don't know, and May or something. And I remember we went out. You're not allowed to fish there, but we went out, my neighbor and I, with a ice auger just to see how thick the lake was, and had 4 feet of kind of like slush, like crap ice, not good stuff, but it was 4 feet, like it was just crazy.
yeah,
Um, I don't know if you remember, but that was an insane year. We just they got like snow hurricanes and that sort of thing.
yeah.
Do you remember what was going on that year?
Yeah, so we had low pressure systems coming in. We had polar vortices, and
Polar
most,
vortex. Yes.
most of the systems were going north and south as opposed to east west, so they stalled. And when they go north-south, they tend to stall over, and they're called Icelandic lows. And we had about three of those storms, and they just circled and circled and circled. And some of them actually came back. And that was a very unusual weather pattern.
Yeah,
And it was because of the polar vortices,
right. So
which,
that's not something you would expect to get all the time. That's like a once in a every couple decades type thing, or once
well,
in a
I'm afraid
lifetime, or
it's going to happen more frequently because of the way it used to be that the jet stream would go from the west to the east. Now it's going north south. So
oh,
getting closer to very cold weather. And if a low pressure system gets caught in that, it's likely to stick around for a while.
oh no. That's I got kids to shovel the driveway now, but uh, we
In
talked
my
about this.
dotage, I've invested in a snowblower.
We touched on this a bit before, but I just wanted to go over it again about how geography affects rain, mountains, plains, and things like a rain shadow. Um, what is a rain shadow? Explain that.
Okay. So what you have, let's say the prevailing wind is coming off the ocean and you happen to have some large hills there. What happens is the air has to push over the top of the hill. And when you raise the air, it cools and it'll
See,
rain. So on the prevailing side of the orogeny or the geography, you'll
right,
have lots of rainfall, lots of snow. And then on the other side, there isn't much moisture left in the air, and it comes down and heats up and actually subtracts the moisture out of the ground. And so
right,
that creates a rain shadow effect. You wind up with no rain in that area on the other side of the hill. And that's in
right,
the lead of the hill. And because the air falls, it gets warmer, heated up, and its capacity to suck up moisture off the ground is increased. So you actually wind up with greater evaporation and a drying effect. So that's called a rain shadow.
yeah, yeah, yeah. Some viewers will talk about that. They'll say, "I'm in this." I think it's somewhere near Washington, Washington State. They have a rain
Yeah.
shadow on the other side, right?
Yeah.
Uh, yeah, I couldn't imagine. Do we? I don't know if we have any effect like that. I mean, we have mountains here, but I guess we don't have real mountains. Uh,
We
oh,
wind up with microclimates where some parts of the Annapolis Valley will get more rainfall than the other, depending whether they're on the lee side or the receiving side of the prevailing winds.
I suppose there is that North Mountain that, in a sense, buffets the valley from the Bay of Fundy,
Yeah,
uh, and then there's the other side, where you've got all that landmass between the South Shore and the valley, and a relatively, I guess it would be all the weather coming off of the southwestern part of Nova Scotia would be kind of rained out before it got to the valley.
that's right.
I lived there for 7 years, and it was a shock moving. I mean, I went to university in Halifax, but you only remember where you've been recently. So I've forgotten how rainy and foggy and slushy it is compared. Like, it really. I lived in Wolfville for about 6 or 7 years, and yeah, it is definitely a little bit more stable there. You can see why it's an agricultural zone. It's just more predictable weather and more favorable conditions. Well, that's all the questions I had for you. Is there anything else you want to
Yeah,
tell
I
us
think
about rain? I think we beat it
we
to death.
covered everything. Yeah, well, this was great.
Yeah, great.
Glad that I finally connected with you, and this is kind of fun. I love doing this kind of stuff. I hope
Great.
it works.
Yeah.
I hope you get a good response out of it. We'll see.
Yeah, no. And yeah, we'll definitely try to have you on again when we got some good questions for you.
Okay, I'll look forward to it.
Great. All right. Thanks a lot, Richard.
Take care, Greg.
Okay.
Bye-bye.
Bye. Thanks a lot.